Hey guys, it's Mr. Dugal, and today we're going to talk about exponential growth compared to proportional growth. So up until this point, we have in middle school math always known growth to be at a rate or proportional, meaning that it's going up by a constant line. When we evaluate slope, for example, we know that slope goes up by the same rate or is proportional. It's a linear growth. So on this side we have linear growth. For every 1 month, it goes up 6 views, and the growth is pretty constant. So we're going to pretend that this is someone tracking their views on social media. And so you can see that for every month it goes up 6. So on the right-hand side, where we see this pattern by adding 6. Horizontally, we see this by taking the unit rate and multiplying it across. The unit rate is 6 views for every 1 month, and it's constant. This is how we've done things for a while now. We can just take the unit rate, multiply across, and it will work out perfectly for us. This is linear growth, and linear growth is proportional. However, not all growth is measured in this way. On the right, we have what's called exponential growth. And exponential growth is very different. On the right side, we see that I'm adding 6 to go from one to the other to keep it proportional. Here, we are multiplying 3 every time, which changes everything. There is still a relationship present. There's still an association or a correlation present, but it's totally different. With linear growth, again, we're adding 6 for every month, or the unit rate is constant. It's going to be another 6 views for every 1 month that we add. However, when it comes to exponential growth, it's not that way. If we were to look at the adding, the first time it goes up by 8, then it goes up by 24, then it goes up by 72, then it goes up by 216. So it does not go up a constant amount. So how do we explain exponential growth? As we explain it like this, when we think about it in terms of exponents from the original, just like unit rate is from the original, we can think that from the original, I'm going to erase these times 3, makes it a little easier to show. The first time, it's times 3. In terms of describing it by times 3 again, the next time, it's by times 3 squared, which would be times 9. 4 times 9 is 36. The next time, it's by times 3 cubed. 3 times 3 times 3 are 27. 4 times 27 is 108. You guessed it, the last time it's times 3 to the 4th power, or 81. And 4 times 81 is 324. So it does follow a pattern does exist, but it's not our proportional linear pattern that we're used to. When we go to graph this, the change starts out slight and then it goes up in a curved formation. Exponential growth is non-linear and it usually follows a curved line pattern. Later in math, we'll learn that an entire curved line like this is called a parabola. We're not going to need to know much with that for the time being, but this is a lot of what calculus is involved around, parabolas. So exponential growth, just in the same way that middle school math revolved very much so around proportional growth, this guy right here, high school and college math a lot of times will revolve around exponential change, exponential growth. Hopefully this helps as a foundation for what exponential growth is. Thanks so much for listening.